In the last few videos, we've been talking about the product rule, which tells us how we can find the derivative of a function which is defined as multiplying two functions together if we know the derivative of the two pieces. The same thing, there's a similar rule that we can prove if we're dividing two functions. And just like the product is what happens when we multiply two things, when we divide things, the answer is a quotient. And so this is going to be called the quotient rule. Let's take a look at what the quotient rule says. This is slightly more complicated than the product rule, but it's the same basic notion. So let f of x and g of x be differentiable functions. Then f of x over g of x is differentiable. Actually, let's throw a couple extra rules in here. We need that g of x has got to be not equal to 0, or else we'd have some dividing by 0 answers. So that is part of our assumptions. And we also want to say then f over g is differentiable at x. We can calculate the derivative of f over g at x. And so that derivative is given by this function here. We take the derivative of f at x, multiply that by g. We subtract this time the derivative of g times f, and then we divide that whole thing by the square of g of x. And here's a slightly different formulation of it using the prime notation instead of the ddx notation to talk about derivatives. So if j is the quotient of two functions, then j prime of x is equal to f prime of x, g of x minus g prime of x, f of x, all over gx squared. All right, so let's take a look at a sample function that we can use to see how we're doing with this. All right, so here's going to be my function. Let's say that we want to find the derivative of k of x is equal to 5x squared over 4x plus 3. Okay, so that's slightly hard to work out. And let me go back to my document camera, which I forgot to do. Boom. All right, so k of x is equal to 5x squared over 4x minus 3. All right, so this is something that we can't simplify using, we can't divide 5x squared by this. So what we're going to do is we're going to use the quotient rule. And just like I did for the product rule, I want to break this into its two pieces. So f of x is my numerator function, which is 5x squared, and g of x is my denominator function, which is 4x plus 3. And what makes the quotient rule work is that we can find the derivative of the numerator and denominator functions. So f prime of x is equal to what? Derivative of 5x squared, you multiply the coefficient times the exponent. So that's 10, and we reduce the exponent by 1. So that becomes 10x. The derivative of g, the derivative of 4x plus 3, the derivative of 4x is 4. The derivative of 3 is 0, so that goes away. All right, and this time, we're going to take f prime of x times g of x. So we're going to multiply these two. And this is going to be our positive thing, and then that's going to be our negative number. Okay? So maybe you can remember that this line has a positive slope and this line has a negative slope to remember which you add and which you subtract. All right, so the derivative of k at x is equal to 10x times 4x plus 3 minus 5x squared times 4, 10x squared, 10x, 4x plus 3, 5x squared times 4, all over g of x quantity squared, which is 4x plus 3 squared. All right, and so we can do a little bit of simplifying here. I don't want to do a super ton. 10x times 4x is 40x squared. 10x times 3 is 30x. minus 5x squared times 4 is 20x squared over 4x plus 3 squared. And so combining our like terms, 40x squared minus 20x squared is 20x squared plus 30x over 4x plus 3 quantity squared. So there is how we can calculate the derivative of the function k, which is the quotient of these two numbers. You'll notice that I didn't expand out 4x plus 3 quantity squared. There's no simplification benefit in doing that. Just having that as our answer is probably as simple as it could be if we wanted to plug some value of x in to figure out what that derivative was. Then having a quadratic thing in the denominator is probably more complicated for doing that than having a linear term which you then square. Okay, so that gives you an idea of how the quotient rule works. Like the product rule, it's something that we're not going to prove, but if you did the limit definition and then a wall of algebra and a wall of limit properties and the definition of what a quotient limit is, limit of a different quotient is, which is what the derivative is, you would come up with this formula here. So we're not going to bother with that because it's not very informative, but that's how you apply the quotient rule. In about a month or so, I'll give you another way that you can remember exactly how the quotient rule works, but we'll need to know the chain rule first in order for that to make any sense. So we'll put that off until after we've learned the chain rule.